There is a 99% chance you have synthetic chemicals in your blood right now that your body cannot break down. And the kicker? You probably never choose to put them there in the first place. These are PFAS, or more commonly known as forever chemicals. They are used in non-stick pans, waterproof clothing, stain-resistant carpets, and even the wrappers your food comes in. They are great at repelling oil and water like magic, and they basically never break down. That is what makes them so useful, but also what makes them so dangerous. PFAS are a large group of synthetic chemicals. There are over 12,000 of them, according to the Environmental Protection Agency. They were first discovered by two researchers, Fritz Schloffer and Otto Scherer, in 1934. It wasn't until more than a decade later, in 1945, that PFAS captured mainstream attention. That year, the DuPont company trademarked a new PFA-based product, one we now famously know as Teflon. What makes PFAS so unique is the carbon-fluorine bond at their core. In chemistry, the bond strength dictates how easy it is for that bond to break. As you increase the number of bonds from single to double to triple, the strength of that bond increases. Chemists use another strategy to increase the strength of bonds, the property of the elements. Organic chemists consider the carbon-fluorine bond to be the strongest single bond possible, and because of that, PFAS don't degrade easily in the environment or in your body. It is true that forever chemicals started in manufacturing plants, but they didn't stay there. Once companies realized just how weirdly useful these substances were, the industrial floodgates opened. So, companies like DuPont and 3M began integrating PFAS into pretty much everything. Non-stick cookware was one of the first big hits, Teflon, which contains PTFE, a type of PFA. And it didn't stop there. If a product needed to be non-stick, water-resistant, or stain-proof, PFAS became the go-to chemical solution. And you might be thinking, okay, that's just good engineering, right? Well, sure, until you realize that PFAS don't just stay in the products. They leak out during production, during use, and long after disposal. Factories discharge PFAS wastewater directly into rivers and streams. Incinerators burn PFAS-containing waste, unknowingly releasing them into the atmosphere. Everyday items like coated textiles and food packaging shed microscopic particles over time. Even washing your waterproof jacket would send PFA particles into the wash water, which would go directly into the environment. Because of poor regulation and zero biodegradability, these chemicals didn't just stick around, they spread into the air, into the soil, into groundwater and oceans. One of the most infamous examples, firefighting foam, especially one called aqueous film forming foam. This stuff is amazing at putting out high-intensity fuel fires, think airplane crashes or fuel depot blazes. That's why it's been used for decades on military bases, at airports, and in firefighter training facilities. But it's absolutely loaded with PFAS, and the problem is, it doesn't just evaporate or disappear, it soaks into the ground. From there, it contaminates the water table. That means PFAS from one training site can end up in the drinking water of an entire town, sometimes miles away. And this has happened over and over again across the US, the UK, Australia, you name it. Studies have found elevated PFAS levels near airports and military facilities all over the world, and these are just the cases we've detected so far. And it gets wilder. Because PFAS are so stable and mobile, scientists have now found them basically everywhere. In Arctic ice cores, in polar bear blood, in rainwater in Tibet, in the Great Lakes, in the deep ocean, even in remote areas of the Amazon rainforest, places you think will be untouched by modern industry. And if you eat, drink, or breathe, they're in you too. And here's the most frustrating part. Many of the companies behind these chemicals knew. As early as the 1970s, 3M had internal studies showing that PFAS were accumulated in the blood of their workers. They knew these chemicals were turning up in blood banks in the general population. They knew, and yet they didn't tell the public. They didn't pull the products, and they didn't sound the alarms. Why? because PFAS were profitable, too useful to walk away from, and unless they were forced to act, they didn't. It wasn't until lawsuits in the early 2000s, particularly those surrounding the contamination of water supplies in West Virginia and Ohio, that internal documents came to light. That's when we learned how much the industry knew and how long they kept it hidden, and now the rest of the world is paying for it. But what does these so-called forever chemicals like PFAS actually do inside your body? We're not talking speculative science. Over the last 2 decades, a mountain of evidence has linked PFAS exposure to a list of health problems you wouldn't want on your worst enemy. First, we have high cholesterol. It might sound like a minor issue, but cholesterol problems are a big deal for your heart and overall health. Studies of populations with known PFAS contamination, like the well-known C8 study in the US, revealed a pattern. The higher the PFAS in the blood, the higher the cholesterol. Here's where it gets a bit scary. PFAS can blunt your immune response, meaning you don't fight off bugs as easily, and vaccines might be less effective. And these aren't just isolated lab findings. The US National Toxicology Program concluded in 2016 that both forever chemicals presumably decreased your ability to mount a robust immune response. Do you want your flu shot to work? PFAS might make it less effective. Next, the thyroid disease. The thyroid is your body's metabolic engine, and if it fails, you're in for trouble. Multiple studies link PFAS exposure to increased risk of hypothyroidism. One analysis from the National Health and Nutrition Examination Survey found that those with higher PFAS in their blood had much higher odds of thyroid issues, especially with women. And now it's time for the C word. The C8 Science Panel, following 70,000 residents in a community with serious PFAS water contamination, found probable links between PFOA and kidney as well as testicular cancer. Later meta-analysis confirmed this risk, especially among people exposed through their drinking water or workplace. Finally, we have developmental problems in children. This is perhaps the most unsettling one. Kids exposed to PFAS in the womb or as infants show higher rates of low birth weight, delayed puberty, and immune issues. Another landmark study from the Faroe Islands found that as PFAS levels increased, children had a weaker response to common childhood vaccines. And while these health effects are most strongly documented in places with contaminated water, you don't have to live next to a chemical factory to be exposed. PFAS are everywhere. The CDC checked and found that 97 to 99% of Americans have measurable levels of PFAS in their blood. Similar findings come from population studies in Europe and even remote Arctic communities. Why? Because PFAS don't go away. Some types, like PFOs, stick around for an average of 5 years in human blood. That means PFAS can build up dose by dose, meal by meal, year after year. In summary, the science is clear. PFAS may be invisible, but their effects on health are real, wide-ranging, and disturbingly persistent. Now, let's talk about why PFAS are so infuriatingly difficult to get rid of. For most common contaminants, give them a little time and they will naturally break down. If not, researchers have different procedures to get rid of them, for example, exposing them to microbes, to the environment, or using water filters to snatch them out of circulation. But PFAS? They are chemistry's ultimate escape artists. These molecules were engineered to last. The unbreakable carbon-fluorine bond in their core is one of the strongest in all of chemistry. It just doesn't let go. Only specialized treatments like high-pressure reverse osmosis can reliably remove them, but that's expensive and not practical for every home. What about breaking them down then? Sunlight, high temperatures, even industrial-scale processes barely make a dent. Research shows that many PFAS are resistant to photolysis, biodegradation, and heat. Some incinerators aren't even hot enough to destroy them, so they will persist in the ash and re-enter the environment. What about wastewater treatment plants? Well, they might as well not bother. Studies find that most plants remove less than 10% of some PFAS, if they remove any at all. The rest flows right back into rivers, lakes, and eventually tap water. Trying to remove PFAS once they are out in the world is, well, imagine trying to catch glitter in a swimming pool using just a fork. Every time you swipe, hundreds of particles slip right through. And here's the catch. Because PFAS bioaccumulates, each new exposure adds to the last. This isn't a one-time risk, it's something that can build up little by little over a lifetime. So here's a question. Are we actually doing anything about these forever chemicals? The good news is, yes, finally. Awareness is rising and with it, real action. First off, we have the regulation. The United States has phased out two of the biggest PFAS offenders, PFOA and PFOs, largely through a 2006 industry commitment supported by pressure of the EPA. Europe acted even faster, restricting them under the Stockholm Convention. With these new restrictions, companies quickly switched to short-chain PFAS, which are smaller molecules that it turns out don't leave our water or our bodies any more willingly. In fact, the scientific consensus is growing that many short-chain substitutes might be just as toxic and more mobile in the environment, and we know disturbingly little about their long-term effects. Next, we have national standards. 2023 marked a turning point. For the first time ever, the US EPA proposed enforceable maximum contaminant levels for 6 PFAS chemicals in drinking water, including the old villains and some new ones. Imagine regulations so strict, they are measured in single-digit parts per trillion. That's comparable to a drop in a swimming pool. Now we have the science to the rescue. But how do you clean something designed to resist everything? Well, if there's something scientists love, it's a challenge, so they have come up with a few possible solutions. The first one is supercritical water oxidation, a process that shreds PFAS molecules apart with heat and pressure, converting them into harmless carbon dioxide, water, and fluoride ions. The US Department of Defense is piloting this type of reactors at military bases heavily contaminated by firefighting foam, and early field studies show it can break down nearly all PFAS molecules. Still, these reactors require extreme heat and pressure, hundreds of degrees Celsius, making them energy intensive and currently costly for large-scale deployment. Another solution is the use of plasma reactors. Think harnessing energized gas balls. These plasma reactors will take a contaminated PFAS solution and blast it with a powerful electrical energy, which will create a plasma bolt that will rip apart the chemical bombs. But not all approaches are about destruction, some are about removal. Activated carbon, which is something like a super charcoal, has been used for decades to filter water, but has only moderate efficiency for PFAS, especially the newer short-chain types. That's where advances in material sciences come in. Modified clays and engineered resins are being designed to selectively grab PFAS from water, acting almost like molecular tweezers. This tech is newer, and is showing particular promise for legacy contamination in soils and groundwater. All of this innovation isn't just happening because scientists and policymakers suddenly woke up. There's been a massive pressure from another front, lawsuits. And we're not talking small claims, but some of the largest settlements in environmental history. Take this. In 2023, chemical giant 3M agreed to pay a mind-blowing $10.3 billion to settle a nationwide class action lawsuit over PFAS contamination in US drinking water system. It just doesn't stop there. DuPont and its related companies, which long manufacture and use PFAS, have already paid over $4 billion in damages and settlements. Much of this is a direct result of plaintiffs, which are often entire towns, proving in court that PFAS in their water pose clear health risk, thanks in part to landmark cases like those chronicled in the film Dark Waters. Here's an uncomfortable truth. Despite decades of widespread use, we barely know what most PFAS chemicals might do to us or the environment. Picture this. There are over 12,000 PFAS compounds, but regulatory agencies and scientists worldwide have only studied a handful. Now, this isn't about sounding the alarm for panic. It's about harnessing the power of knowledge. After all, the more we know, the better choices we can make, both as an individual and as a society. So what can you actually do? You can start by supporting bans and stronger regulations. policies work. A strong government intervention is one of the most effective ways to reduce PFAS exposure across populations. Public advocacy led to the phase-out of PFOAs and PFOs and continues to push for broader regulation. You can also check your local water utility reports. More water companies now report PFA levels, often because of new EPA guidelines. Knowing what's in your water is the first line of defense, and in the US, you can usually find annual water quality summaries online. If levels exceed health guidelines, you can press for local action. Finally, you can avoid PFA-containing products. Most PFAS exposure comes from products we use every day. Look for that PFA-free label. Or you can also check the constantly updated guide to which consumer products may contain PFAS and which don't, which was created by the Environmental Working Group. This is a global challenge, but you're not powerless. Your choices, what you buy, how you filter your water, how you vote, and what you demand from companies move the needle far more than what you think. Don't forget to like this video, subscribe for more deep dives, and hit the bell so you never miss an episode. Stay curious, stay healthy. Until next time.